Hello class, this is a video tutorial on exponential equations revisited. So prior to knowing logarithms, we solved exponential equations by the use of index laws and observation. So one of the techniques that we did is that we converted all the expressions to the same base, like so, 5 and 25. Well, 25 becomes 5 squared, and 8 becomes base 2. 4 also becomes base 2. Once we've changed these using index laws, we saw that these indices should match. So from here, x equals 4. In this example, 2x minus 1 equals 2, which we can solve using linear equations. And likewise with this, 3x equals 2, which we can also solve using linear equations. But by now utilizing logarithms and other log laws, we can actually solve exponential equations more easily and solve more difficult exponential equations, such as this one, where we can't change the base to the same thing. For example, we don't know e to the power of something giving us 100. So for this, we would definitely have to use log laws. So here's how we do this. And so you can pause at any time and give this a go once you understand the concept. So the idea here is like what we do with equation solvings. What you do to the left, you can also do to the right. So the new function that we can work with is taking the log of both sides. So it would look something like this. We can take the log of both sides. I can't fit it in this question, but we're taking log of 81 here. Using log laws, since this is log of 3 to the power of x, that x moves to the front, which becomes x log of 3 equals log 81. Now from this point, log of 3 is just a number. So this you can think of as x times some number, whatever log 3 is. So we can make x by itself by dividing both sides by log of 3. And this will get us x is equal to log 81. Sorry, I could rewrite this again, but from here we just take the input of this in our calculator. So log 81 over log of 3. And as you can see here, x is equal to 4. Now, the log base that we take can be anything. In this case, remember, if we don't write what the base of this log is, it is assumed to be 10. But I'm going to demonstrate to you in this next one that it doesn't matter what base of log we take, so long as it is the exact same base. So in this case, you could actually take the ln of both sides, and just like we do with the log laws, this power will now move to the front. It'll be 2x minus 1 times ln 5 equals ln 25. Once again from here, this is just a number that we can divide out, so dividing ln of 5 on both sides, which will cancel out these two, leaving us with 2x minus 1 equals. Now at this point, you should check whether this gives an exact result or not. So for example, ln of 25 over ln of 5, that gives us 2. Well then from here, we can solve this equation like we normally would. So this becomes 2x equals 3, x equals 3 over 2. Now keep in mind this idea that I showed here, that you should check whether this becomes a integer or a nice result. So I'll demonstrate to you in this one what I mean here. So in this example, just to really show again, it doesn't matter what base log we take. So for this, I'll switch back to log. So this is base 10, and I do that for this one as well. So these two, well, this will now move to the front. This becomes 3.4x log of e. Now this, if you take a look, this is log base 10 of 100. This can indeed simplify. So this, if you just check your calculator, becomes log 100 becomes 2. But now we have to keep this in exact form. Okay, so for this, notice how we can divide 3.4 and log of e. So we're dividing by 3.4 log e. This cancels out the 3.4 and the log e, leaving us with x on its own. But we have to do this to the right-hand side as well. 3.4 log e. So x is now equal to, in exact form, 2 over 3.4 log e. This is the exact result of this problem, but so that we can take an approximate decimal solution, we take the input in our calculator, 2 over 3.4 log of e. This gives us approximately 1.354, but I'm going to leave this to 2 decimal places, like so. All right, so I hope that gave you an insight into how we can solve exponential equations by the use of logarithms. Hope to see you in the next video, and best of luck.